Yeah, very good morning to everyone. So today we will see one more data structure, that is linked list. So today in the coming classes, probably this whole week, we will spend some time learning how to develop this linked list data structure. Okay, so already we have seen how two data structures, the linear data structures we have discussed in the previous week. So we talked about the stack and linked list, the implementation of stack. Sorry, we talked about the stack and queue in the previous week, and we learned how to develop either stack or queue uh, using array. So today we will talk about linked list, and I will tell you how to implement uh, stack using uh, linked list. So then you will get an idea about both the linked list as well as the implementation of stack using the linked list. Okay, so what is a first? Let me talk about the linked list here. So it is a linear data structure. I hope my screen is visible to you, right?
Yes, sir.
Yeah, thank you.
Yes, sir.
Fine.
Yes, sir.
Okay, thank you. Fine. So now, what is a list here? A linear linked list can be defined as a collection of variable number of data items called as node. So here, what you are going to do here is you are going to generate an element which is called as a node. Now here at the bottom, if you observe the figure, so it is actually called as a node. So a node actually consists of lists are more, node actually consists of the information part and the link part, or you can say the address part. So the information part actually contains whatever the information which we want to store, and the link part actually contains the address here. So when you're creating a linked list here, so we first generate a node, then we'll save the information, and this address part actually contains the link part, or the address part contains the address of the next node. Okay, so the beginning node, the first node address will be stored in a pointer, and of course the address of the next node is also stored in a pointer. So whenever you want to generate a new node, what you are going to do, you're simply going to, you're simply going to generate a new node. Like here node 3 is there. If I want node 4, simply I will create a node, I will add the information, and the link in the link part of the node 3, I will store the address of the next node, so that whenever I want to traverse from the node, whenever I want to whenever I want the information stored in all the nodes, I will go to the beginning address which is stored in start pointer, or you can call it as an head, or you can call it as an begin there. You'll go there, you go to the first node, you'll gather the information, then you will take the address of the next node, then you will go to the next node, you will take the information, then again you will go to the next node, you will take the address of the next node, then you will go to the uh, next node. Like that you are going to move on until you come across null. Once you get to null, then you can say that it is the end of the list here. So that is what actually the linked list here. So the linked list can be of two types. Okay, the linear and circular linked list. So in linear, you can say it's a single linked list, single linear linked list, and a double linear linked list. Then if you go to the circular linked list, you have single circular linked list and double circular linked list. Okay, so first today we will just talk about the single linked list. A single linked list contains only two fields. Okay, it contains two fields in each node, an information field and a link field. The information field contains the data of that node. So whatever the data which you want to store will be there in this information part. The link field contains the memory address of the next node. It will contain the memory address of the next node. Okay, there is only one link field in each node. The linked list is called, if there is one link field in each node, then it is called as a single linked list. Okay, so this is a graphical representation. Next, Just a second. Okay. Okay. Next, just hold on for 1 second. Just hold on for 1 second. So just I got a message for that there will be a power cut. So better I will log in with my mobile data so that having power cut means any disturbance. Oh, can you hear me?
Yes, sir.
You people there? Can you hear me?
వినబడుతుంది సార్.
Okay, thank you. Okay. Okay, fine. The next type of linked list we have will be the double linked list. In the double linked list, now each node contains three parts. Each node contains three parts: the information part, the link, the address part, which means one of the address part which stores the address of the next node, and one of the address part which stores the address of the previous node. Okay, so the address of the first node is stored in a pointer. Okay, then you have a pointer which stores the address of the next node so that you can move to the forward direction. And then we have an address bar which stores the address of the previous node. So which means you can move in the backward direction also. Means you can move in the front direction as well as in backward direction also in case of double linked list. Okay, so in case of circular linked list, it is a single linked list. It is single linked list, means it is similar to your single linked list. The only difference here between the circular linked list and single linked list here is, see, in the single linked list, the address part, the address part of the last node contains null. Whereas in case of single circular linked list, the address part of the last node contains the address of the first node. So that after reaching to the last node, again you can come back to the first node and again you can traverse from the beginning here. Means in whatever position you are there, you can traverse the entire list here in case of circular linked list. But in case of single linked list, if you are at some middle of the list there, you can simply move in the forward direction. You cannot go into the backward direction. Means you cannot retrieve the backward nodes there. So whereas in case of double linked list, now this is also possible. So from wherever position you can go front and you can come back, but you cannot rotate through the entire list there. But whereas in case of double circular linked list here, the address part of the last node will contain the address of the first node, and the address part of the previous node will contain the address of the last node. So that from any node you can traverse through the entire list either in the forward direction as well as in backward direction. Okay, so that is the type of linked list we have. So in the coming classes, we will observe, we will develop all kinds of linked lists there. So we will try to develop the 4 different types of linked list: the single,
సార్ చిన్న
circular,
డిస్టర్బెన్స్ వస్తుంది సార్ వాయిస్ తో
pluricircular,
పాటు.
double. Ma?
బ్యాక్గ్రౌండ్ చిన్న డిస్టర్బెన్స్ గా
Disturbance,
వస్తుంది.
huh?
చిన్నది వస్తుంది సార్.
ఈ మొబైల్ డేటాతో కనెక్ట్ చేసిన పవర్ పోతుందేమో అని. క్లారిటీ ఉందా వాయిస్ లేదా?
వాయిస్
ఇప్పుడు
క్లారిటీగానే ఉంది సార్. వాయిస్ క్లారిటీగానే ఉంది. చెప్తున్నప్పుడు చిన్న డిస్టర్బెన్స్ వస్తుంది సార్ అలాగా.
Now, how about now? ఇప్పుడు
ఓకే
how
సార్.
about now?
ఓకే సార్.
Fine. Now, okay, fine. Now, the operations on the linker list that are performed are: first, you need to create a linker list. You can traversing the linker list. Traversing the linker list means you are going to visit all the nodes there. You can insert an element to the list there. You can delete the item from a list. You can remove an element from a list. You can search for an item in a linker list and merging two or more linked lists. You can merge two or more linked lists. So these are types of operations which you can perform. Today we will see how to means the insertion of an element in a linked list, then traversing through the linked list and deleting an item from a linked list there. Okay, so these are all operations we will see in case of single linked list today. So creating a linked list, nodes of the linked list can be created by the structure declaration. Means you generally use a structure to create a linked list declaration here. Okay, so you create a structure where you place all the information, whatever the type of information which you want to store, you put it in a structure. Then you will have a pointer here which will store the address of the next node. Means this pointer. So this pointer, the next pointer here. The link pointer is there. So the link pointer which stores the address of the first node, address of the node will be, that pointer will be created. Then you will have the other pointers, required pointers. I will discuss this clearly while I explain the program. Now, the link field contains a pointer where that refers to the same node structure. No, the link field, generally this particular thing will have a pointer which refers to the same node structure. So this is a self-addressing pointer, so which addresses the same structure node. Okay, then we have operations new and delete there. So operators new allocate the memory space and delete deallocates the memory space. So here we generally use malloc and malloc functions so as to create the memory and free the memory once it is released. Then we have the traversing algorithm where if already some existing list is there, what we are going to do here is you are going to create a pointer p which will be assigned to the beginning node. Then while p not equal to null, means p when p is not equal to null, you will process the data, you will fetch the data, then you will move on to the next node. So p will be assigned to start, then p not equal to null. While p not equal to null in the sense, if p is null, the traversing will be stopped. Okay, so you'll process the data in the p, the node p, then you'll move on to the next node. Okay, so this is traversing. I will show you, I will show the same in the program. Okay, then you have insertion at the beginning of the linked list, insertion of a node at the given position, and insertion of a node at the end of the linked list. So today we will just see how to insert a node at the beginning here. Okay, the remaining two, once we get comfortable with today's creation, then we will talk about those two things in the later classes. Okay, so inserting a node at the beginning here. When you want to insert a node at the beginning, what you are going to do here is you are going to first create a node. Now you create a node, then what you are supposed to do here is fill the data into the data field, mark the pointer field as null. Means you just see this is a new node which is created. So the number 12 is the information. Now here it is containing null there, and already we are having an existing list here, existing list. Now what I have to do, if I want to add it to the beginning, this 12 should come to the front there. This 12 should come to the front. Okay, then simply see here how nicely he has linked it. So the next address part of this node, the new node which is created is linked to the previous list there, and the first pointer is saved with this address. Got it? See nicely how he has linked it. So already we are having a list. Already list ఇక్కడ ఒకటి ఉందండి. So 7 information తో 11 information. మనం 12 అనే ఇన్ఫర్మేషన్ తో ఒక లిస్ట్ ని క్రియేట్ చేసాం. ఇప్పుడు ఇది ఫస్ట్ నోడ్ అవ్వాలి. ఇది ఫస్ట్ నోడ్ అవ్వాలంటే ఏం చేసాం మనం? దీని యొక్క నెక్స్ట్ అంటే 12 ఇన్ఫర్మేషన్ ఉన్న నోడ్ లో నెక్స్ట్ పాయింటర్ లో ఏం చేసాం? ఈ 7 ఇన్ఫర్మేషన్ ఉన్న నోడ్ తాలూకా అడ్రస్ ని స్టోర్ చేసాం. సో ఇక్కడ కింద చూడండి మనం లింక్అప్ చేసాం. లింక్అప్ చేసిన తర్వాత ఇప్పుడు ఈ 12 అన్న నోడ్ ఉన్న మీన్స్ 12 ఇన్ఫర్మేషన్ ఉన్న నోడ్ ఫస్ట్ నోడ్ అయింది కాబట్టి ఫస్ట్ పాయింటర్ తాలూకా అడ్రస్ ని మనం ఏం చేసాం? మార్చేసినప్పుడు ఇప్పుడు ఫస్ట్ నోడ్ ఏమైపోయింది మనకి? ఈ యొక్క 12 అయిపోయిందండి. అర్థమైందండి ఇది? Did you understood or not? Andy, respond.
Yes, sir. Yes, sir. The sir.
Yes, sir.
Yeah. Thank you. Thank you. So that is how we are going to go with the front here. Okay. Next, this is the algorithm. So creation of a new node, then insertion of data into that, then link of p is equals to start, and start is equals to p. Link of p is equals to start. Means see here, link of p in the sense this one. Link of p. This is the new node which is created is equals to start. Start is stored in that. Then we have start is made as p and you are going to return. I will show you clearly in the program once we discuss. Now this is about inserting node at the last. I'm not going to discuss it today. I will discuss it in the next class. Okay. Then we have the inserting node at the at a given position. We will see that also later on. Now here deleting the node from the list. So deletion of the node. Now I just want to delete the node from the beginning. So I can delete the node, the first node, I can delete the last node, and I can delete a node at a given position. So in such cases, what happens? Now again, we will see only how to delete the node, the first node here. Now see here, if I want to delete the node which is having the information 12, simply you move the first pointer here. You move the first pointer to the next node. Means you are already having the address here. అంటే 12 ఇన్ఫర్మేషన్ ఉన్న నోడ్ లో ఆల్రెడీ నెక్స్ట్ పాయింటర్ తాలూకా అడ్రస్ ఉంది. ఆ అడ్రస్ ని మీరు ఏం చేస్తారు? ఫస్ట్ పాయింటర్ లో స్టోర్ చేయండి. ఈ నోడ్ ఏమైందండి? ఆటోమేటిక్ గా మనకి డిలీట్ అయిపోయిందండి. ఓకే, దిస్ ఇస్ హౌ వి కెన్ డూ ఇట్ వైల్ డిలీటింగ్. ఓకే, నెక్స్ట్ see here the start p2 is equals to start. So p2 is a pointer. We are having this is deleting at the end. So it is not deleting at the beginning, deleting at the end. We will discuss about ending later on. So that's it. So I will now discuss with you the program. So observe it very carefully. Now observe here. So now first thing which I have done here is I have created a structure. See, this is structure. First, understand the structure carefully. So for creation of the list, as I just discussed, that we need to create a structure. Now this structure actually is storing an information. It is going to store a name and a phone number. I just want to store the name of a person and their phone number in this structure. So I have included those two things here in the structure. Then I have a structure pointer, the self-referencing pointer, structure phone next. This next pointer actually stores the address of the next node. So when I create a list here, it is going to store the address of the next node. Okay, like for instance, for suppose, now this is what is the structure. So this is the means. Now this is the next. This is the information part. The first thing. The second one is the next part. Okay, this is the next part. Then I'm having a pointer called head, which is also, this head pointer is also of structure phone. This head pointer is of structure phone, which is stored to null. Got it? Then I have three functions: the prototyping, insert at the beginning, remove, and display. Three functions I have written here. Okay. Did you understood this structure, everybody?
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Okay.
sir.
Now,
Yes,
and I have
sir.
a main function, so which is going to take a choice here. So while one, so see, insert a node at the front, delete a node at the beginning, view and quit. So then I have entered a choice, then I have entered it. Okay, now switch CH. So if it is case 1, it is inserting the node at the beginning. Then if it is remove, it is removing the node at the end. Then I have display, which is actually displaying the whole list there, the elements in the list, and 0 for exit and for invalid choice. Okay, now just before I discuss the code, let me just once execute this program and show you. Observe the working execution very carefully. Now first I'm entering 1. See, I entered 3. No list is there. So 3. No nodes exist. Message there. No nodes exist. Now I am saying, so if I enter choice 1, what is the name? So some name I have entered, some Prasad. Then what is the phone number? So some phone number. Then again it is asking. So again I am saying 1. So before 1, see 3. Name is Prasad, phone number is 9. Now again I have entered choice as 1. Now this time some Pramod. And from some phone number, this one. Again see 3 view. See, Pramod is shown first, then Prasad. Means Pramod is added to the front of the list. It is added to the front of the list. So again I am adding some third one. Some Ravi, then phone number, then again if I say 3, so Ravi will be added first, then Pramod, then Prasad. Fine. Now I want to remove the element 2 entered. Node is deleted. Now if I say 3, so which one will be deleted? So because Ravi is at front, Ravi will be removed. So last in, first out. This is what is the implementation of the stack. Ravi should be removed. So if I say 3, now observe Pramod and Prasad are there. So Prasad is entered at the beginning, so it is shown last. So Pramod is also there. Now Ravi is removed. In the sense, the meaning of that is the node which contains Ravi will be removed. Last in, first out. The one which is entered last will be removed first. So again, if I say 1, now this time I say Kalyan. Okay. When I say number 2, 2, 2. Now again 3. So see, Kalyan will be added at the front. Okay. Then if I say 2, node is deleted. Kalyan is deleted. 2. Pramod is deleted. Again, if I say 3, only Prasad is shown. If I say again 3, that node is also deleted. Now, if I again say 3, no nodes existing. So this time 3, no nodes exist. Got it? So this is what is the execution here. Now, let me execute the code now. Now see here, this is what is the choice. Insertion at the beginning. Now in the insertion, see one thing here. Now this head is global. It can be accessed by any function, global. Now coming to the case of insertion, how it is done, you observe it very carefully. Now for suppose we are having head. Okay. Head pointer. Now phone P. Struct phone P. So P is equals to struct phone of malloc of size of struct phone. Now a point means a node is created. A node is created. So which is actually pointed by P. Which is actually pointed by P. Fine. This is pointed by P. Okay, this memory. Now a flash stdin, enter name, some name is inserted. So Prasad is inserted. Then enter phone number, some phone number is inserted. Then I say, see, enter name, enter. So P of next. This is P of next. P of name is this one. P of phone number is this one. P of next is stored as null. This is stored as null. Now next, is head is equals to P, true or false? As head is P, head is null because in the beginning, because it is the first node, so already we have assigned head to the null. So because of that, head contains null. Because the head contains null, so head is null. So now what happens here is head is equals to null, then head is equals to P. Head is equals to P in the sense the head is also pointing to P. Head is also pointing to P. Then it won't go. Again, you asked for a new node. So again, it comes here. P is equals to struct phone number. This time, this P no. This is not P. This is P. This is P node. Now again enter name. So you just like to enter the name. So for example, Pramod, and the phone number is something which is entered. Then again P of next is equals to null. P of next is equals to null. Then is head is equals to P? No. Is head is equals to null. This time head is not null. This time head is not null. So therefore it comes to the next part, else part. So P of next is equals to head. So what is P of next? So this one. P of next is equals to head. Head in the sense the address of this one. Already head contains the address of this node. The node which contains the information about Prasad contains null. Now this null will be removed. Null will be removed and it is pointing to this node. Then what next I am doing? Head is equals to P. Now head is moved to this node now. See here, if I want to traverse, I will take the head address. Head address is this node now. Pramod means it comes here. It will take the information from here. From again, it will take the address of the next node. It will go there. Got it? How we have linked? Did you understood or not?
Yes, sir.
Understood?
Yes, sir.
Yes, sir.
Yes, sir.
Please respond.
Yes,
Did you
sir.
understand, ma?
Yes, sir.
Sir,
Okay. So like that, you can create another node also. Say for example, third time if I am creating another node.
Hello.
Hello.
Hello, Sati.
Sir left.
సార్ లెఫ్ట్ అయ్యారేంటి?
నువ్వు చెప్పే క్లాస్
ఆహా, వింటారా?
Sit. Are you there?
Yes, sir.
Yes,
Yes, sir.
sir.
Yes, sir.
Yes, sir.
సార్ మళ్ళీ లిఫ్ట్ అయ్యారు. హలో.
సార్కి
అదే
టెక్నికల్ ఇష్యూ
క్లాస్ సార్ రేపు చెప్తారంట.
కంటిన్యూ చేస్తానని చెప్పారు.
అది అందరు లెఫ్ట్ అవ్వండి ఇంకా. రే సత్తి
अरे दानी